All right. So let's continue. Now the next. That is the capillary in the brain. And of course, you know capillaries are single cell layer. So they form what? Endothelial cells. So these are the endothelial cells. Can somebody just go to this lesson quickly, please? That is www.acavetsolutions.com. Let's see if something comes up. So I just got crazy this morning. I don't know what's happening there. Nothing came up? Nothing came up? Sure. Okay. I think I tried it this morning and something came up. Can you try this?
Oh, wait.
Are you sure you got the right thing? Acavetsolutions. I didn't know that you had
It's
it.
a .edu.
This is .com. Sorry.
It's not working.
Not working yet?
No.
Okay. Let me see. We need to reload that.
There's no R. Is this what's coming up? It's Alphabet.
Let me see.
Alphabet.com?
No, this is a case.
Let me see. Yes, this is something. Okay, it's supposed to be Acavet. Sorry. Oh, washing. You know, it's always good to. So let's try. Can we try that?
Yep, that works.
There you go.
Something coming up?
Yeah.
Okay. Okay. So, I think I don't know because I'm a novice in this kind of a thing. So we've got, I've been complaining last semester, right? So this is where we are now, and I think we have gotten to this point where you can subscribe to it. I think so. But I tried getting to the point of subscription, and I got something like this. It told me you can't order this plan at the moment. It says, please contact us to complete the purchase stuff. So I've gotten to my, what's it called? To my manager, the person that manages the website, to sort it out and all of that. So, like I said, I'm a novice in this kind of a thing. So that is it. So you might just, well, for each of the, you have like,
That's not bad pricing.
what?
It's pretty good pricing.
Yeah.
Very reasonable.
So we have some different plans for that, and that means that if I sort it out with how, I don't know how it works, but if we can navigate to the payment plan and all of that, then we put that on. So you have the opportunity of accessing at least for now, because we are still at the preliminary stage, you can access 200 questions, multiple choice questions per system, right? So we have all the systems, all the aspects of veterinary physiology have been covered, from cell physiology down to the entire systems of the body have been covered, and then in that package you have access to some access to. Don't want blood here. You don't want the solids to leak into the brain. Right? So there must be something to limit this opening. So what astrocytes do as cells is to come and limit. They attach to the capillaries, the capillary brain, capillary endothelial pores. So they attach. Can you see that the opening is now it's very small? That's what astrocytes do. They attach to it, leaving a very tiny window. Leaving a very tiny window. So this creates a significant barrier to the movement of solids out of blood into the brain interstitium. That is how the astrocyte does this. Then, like any other glial cells, they also produce neurotrophic factors. And so, the choroid plexus. The choroid plexus are a group of cells which line the inner walls of the brain ventricles, and they are supposed to be separated from blood vessels. These ependymal cells provide the separation between the blood vessels, the blood ventricle, and between the cells that form the choroid plexus of the ventricles, and so it stays in between. It tries to compartmentalize them. So in other words, it is involved in the formation of cerebrospinal fluid by helping to provide anchorage to the choroid plexus and separating them from the blood vessels. So they provide barriers between different compartments of the brain ventricles. So let me repeat it so that we won't say we don't know. Remember, this is short and this is long. So this qualifies for sympathetic right, and this qualifies for parasympathetic right. The preganglionic is long. In the parasympathetic, it is short. So take note of that, very important. So at this point, this is the target tissue, acetylcholine. This is the ganglia, acetylcholine. This is acetylcholine. And this is what? Norepinephrine. But if we say this to sweat glands, this will also be what? Does that make sense? Does that make sense? Does that make sense? At all ganglia, acetylcholine, both sympathetic ganglia. Then at the postganglionic end of sympathetic, that is why you find norepinephrine. But an exception to this is what? The sweat gland. And then at the postganglionic fiber of the parasympathetic, you will still find acetylcholine. So acetylcholine is released everywhere in the autonomic nervous system except the postganglionic fiber of the sympathetic, with the exception of the sweat gland. That's where you find this. Norepinephrine is released only at the non-postganglionic fiber. So basically, neurotransmitter effect, release and effect is the primary for any fiber that secretes acetylcholine is described as cholinergic. So preganglionic of parasympathetic and postganglionic of parasympathetic are described as cholinergic. Preganglionic of sympathetic is also described as cholinergic, as well as postganglionic fiber of the sympathetic going to the sweat gland is also considered cholinergic. So cholinergic fibers would be 1. So we have nicotinic effect here. If this is inhibitory, do you think this will be excited? So, and if this is not excited, this organ will not be excited, will not be regulated. So this side, this is only this. So there should be the type of receptor here should be such that will allow electrical current to move through. So nicotinic receptors are always excitatory. But it is not like that for muscarinic. Muscarinic can be both excitatory or inhibitory, depending on the type of effects desired on the tissue or organ. So the postganglionic fiber of the parasympathetic system. They are usually found in the tissue, that is the postganglionic, supplying organs like the heart, smooth muscles, the exocrine gland, including the GIT, the trachea, and all of that. So if I want, we can also expand this. Let's expand this. Let's expand this.